All right, let's take a look at the practice test. For the instructions, we're asked to find the partial fraction decomposition of each. All right, before we jump in and look at any of the problems today, we're going to cover the procedure for the partial fraction decomposition of f of x, which is our numerator, over g of x, which is our denominator. All right, for these problems, the first thing you always want to do is check to make sure that you do have a proper fraction. Most of the problems you get are going to be proper fractions, and so just pay close attention, because if you don't have a proper fraction, you want to stop and perform a polynomial long division first, and then apply the steps to the remainder. When we talk about a proper fraction and you're dealing with a rational expression, well, that means that the degree of the numerator is strictly less. So it cannot be equal and it cannot be greater than the degree of the denominator. So I have two examples here. So one for a proper and one for an improper. So for the proper fraction, we have x over x squared plus x plus 5. The degree of the numerator is 1. The degree of the denominator is 2. For the improper fraction, you have 2x squared over x plus 3. The degree of the numerator is 2. The degree of the denominator is 1. So if you get an improper fraction, you have to stop, do the polynomial long division, and then apply these steps that I'm going to go through to the remainder. Okay, the next thing you want to do is factor the denominator. So that's your g of x completely into factors of the form. So your ax plus b, so that's going to be a linear factor, to the power of n, where n is a positive integer. So 1, 2, 3, 4, so on and so forth. And then you have this cx squared plus dx plus e to the power of m, where m is a positive integer. So again, 1, 2, 3, 4, again, so on and so forth, where this cx squared plus dx plus e is irreducible over the rational numbers. So I'm going to stop here for a moment, and I'm going to make sure that that's crystal clear for you, because some people get confused. When you hear the word irreducible, it depends on what number system you're working with. So let's say I had something like x squared and then plus 1. Can I factor this using real numbers? The answer is no. I would have to use the complex number system if I wanted to factor that. To see this, you could just set this equal to 0, and you could subtract 1 away from each side. You could cancel this. Say x squared is equal to -1. From the square root property, you would say x is equal to plus or minus the square root of -1. And we know that the square root of -1 is the imaginary unit I. So you could say x is equal to plus or minus I there. So that means this right here would factor into the quantity x plus I times the quantity x minus I. But would you want to do that? No, because this guy right here is irreducible over the real numbers, and it's irreducible over the rational numbers. And we are concerned in this section with something being irreducible over the rational numbers. So if I cannot factor it using rational numbers, I don't want to. So for something like this, just write it like this. It's an irreducible quadratic in this section. As another example, let's say we had x squared and then -2. Can I factor this using rational numbers? No, but I can factor it using real numbers. So it's irreducible over the rational numbers, but it's reducible over the real numbers. I could say this is x plus the square root of 2. Remember, that's an irrational number. And then times your x minus the square root of 2. So you could factor this, but you wouldn't want to because it's irreducible over the rational numbers. Leave it like this. If you got something like, let's say, x squared, let me fix that, minus 5x plus 6. Can I factor this using rational numbers? Or to keep it simpler, can I factor this using integers? Well, I want two integers whose sum is -5 and whose product is positive 6. Well, that's -2 and -3. So this is x minus 2 and then times x minus 3. Remember that a number like -2, that's an integer, but you could write it over 1. It's also a rational number. So this guy right here is not irreducible over the rational numbers because you could factor it using this -2 and this -3 here. So you would not want to write it like this. You would want to factor it into this. So it's very important to know when you should factor and when you shouldn't factor. If something is irreducible or not factorable using rational numbers, do not factor it. If something is reducible or factorable using rational numbers, then factor it. That's the simple way to think about it. All right, then the next thing you want to do is say for each distinct, and that just means different, linear factor, so your ax plus b, we produce a partial fraction. So this is a capital A here, which is going to be representing an unknown constant, over your factor, which is ax plus b. When you get a repeated linear factor, so something like ax plus b to the power of n, where n is greater than 1, you have to do this pattern right here. So you want one fraction with an unknown constant in the numerator for each power of this guy. So let me show you that real quick. Again, we talked about that in the last section, but let's say you had something like x plus 2, and let's say you had x minus 3. So these are distinct linear factors. When you set this up, you want a over x plus 2, and then plus b over x minus 3. So it's just an unknown constant in the numerator over each distinct or different factor. So this is your unknown constant for this x plus 2. This is your unknown constant for this x minus 3. That's how it works. If you had something like x plus 2, and this was a quantity squared, let's say, Well, then you have to do a over x plus 2. So that's for the first power. Then plus b over x plus 2 quantity squared. If this was cubed, you'd have to keep going. So plus, let me actually make this a little bit longer. C over x plus 2 cubed. Let me make that better. So coming back, now you're going to do the same basic thing for each distinct, or again, different quadratic factor. Remember, this is an irreducible quadratic, so cx squared plus dx plus e. We're going to produce a partial fraction. So now it's bx plus c over cx squared plus dx plus e. Then for each repeated quadratic factor, again, cx squared plus dx plus e to the power of m, where m is greater than 1, you have to follow this pattern here. So again, if you had something like, let's say, x squared, and let's go plus 5x, and then plus 7. This is not something you can factor using rational numbers. So what we would do is we would write our ax plus b like this over this guy right here. So x squared plus 5x plus 7. And then again, if this was squared, well, then you go plus cx plus d over this x squared plus 5x plus 7 quantity squared. Again, you've got to have one of these fractions for each power of this guy. This is the first power. This is the second power. The next thing you're going to do is set the original rational expression equal to the sum of the partial fractions. You're going to see that I'm going to do that as I'm setting up the problem. Also, if you had to do a polynomial long division first, when we say original rational expression, that's going to be the rational expression that was created from the polynomial long division when you took your remainder and put it over your divisor. All right, the last thing you're going to do is solve for your unknowns. So in most cases, you're going to set up a system of linear equations, and again, solve for your a, your b, your c, so on and so forth. You can clear all denominators to multiply both sides by the LCD, write both sides in descending powers of x, equate the coefficients of like powers of x, equate the constant terms, and then solve the given system using algebraic methods. Like we talked about in the last section, there are some strategic substitutions that you can make to make your life a lot easier. So you don't always have to go through and set up a linear system, but in some cases you have to, and in every single case it's going to work if you want to do that, even though it might not be the fastest approach. All right, for the first problem, we're given negative 3x cubed minus 14x squared plus 8x minus 63, and this is over x to the fourth power plus 2x cubed minus x squared plus 4x minus 6. So the first thing we're going to do is figure out if we have a proper fraction, which means that the degree of the numerator is strictly less than the degree of the denominator, or an improper fraction, and that would occur when the degree of the numerator is the same as or greater than the degree of the denominator. So in this particular case, if you look at your numerator, what's the highest exponent on x? Well, that's going to be a 3. So that tells me the degree of the numerator is 3. When I look at the denominator, what's the highest exponent on x? Well, that's going to be this 4 right here. So the degree of the denominator is 4. So since the degree of the numerator is 3, and that's less than the degree of the denominator, which is 4, this is going to be a proper fraction. And so where I have factored the denominator, the first thing you'll see is that I made a group that is quadratic in form. So this is equal to the quantity x to the fourth power minus x squared minus 6. That's coming from this guy, and then this guy, and then this guy. Then plus, you have this other group. So that's going to be your 2x cubed plus 4x. That's going to be this guy, and then this guy. So again, I'm just rearranging things and then grouping things by putting them in parentheses. So you'll notice that this guy right here is quadratic in form, and so you could factor it pretty easily. Let me show you that, just in case you're a little bit lost. Remember, you can do this using substitution. You don't have to, but a lot of people find it easier. So you could rewrite this as x squared squared minus x squared and then minus 6. You can let u be equal to x squared, and then this right here would be u squared minus u minus 6. You want two integers that sum to -1 and have a product of -6. Well, that's going to be -3 and +2. So when you factor this, you get u minus 3 times this u plus 2. So then if you just replace u with x squared, well, then you could say this is going to be x squared minus 3 and then times x squared plus 2. So coming back, this x to the fourth power minus x squared minus 6 factors into this quantity x squared minus 3 times this quantity x squared plus 2. Over here, you have this 2x cubed plus 4x. Well, if you pull out a 2x, this is going to be plus 2x times the quantity x squared plus 2. Okay, so now you'll notice that you have a common binomial factor. So you have this x squared plus 2 and this x squared plus 2. So we can pull that out. So that is going to go right here. And then inside the parentheses, you're going to have what's left. So you have this x squared minus 3 and then plus this 2x. I just rearranged it to x squared plus 2x minus 3 so that we could factor. Remember, you're looking for two integers that sum to 2 and have a product of -3. So that's going to be -1 and then positive 3. So this factors completely into this x squared plus 2, then times this x minus 1, then times this x plus 3. Remember, this x squared plus 2 is going to be irreducible over the rational numbers, so you leave it alone, you do not factor it. Okay, once you have factored your denominator, you're going to move on and set up the partial fraction decomposition. So you have your denominator here, which is x minus 1, then times x plus 3, then times this x squared plus 2. So again, this is the factored form. And I just replaced the denominator with the factored form to make it easy. So you're going to say this equals your a over x minus 1. So that's coming from this guy right here. Then plus your b over your x plus 3. So that's coming from this guy right here. Then plus, again, if you have an irreducible quadratic in the denominator, you have to do this differently. So you want cx plus d over your x squared plus 2. So this is going to be linear in the numerator because you have a quadratic in the denominator. It's always going to be 1 degree less in the numerator than what you have in the denominator. So this is coming from this guy right there. So once you've set this up, you're going to multiply both sides by the LCD, which is just that denominator of the original rational expression. That's what it's always going to be. Now, I cannot fit this on the screen, so I have to break this up and do it in pieces, and then I'll reassemble it in the end. So for this guy, this is going to cancel with this, and you're going to have that numerator, so negative 3x cubed minus 14x squared plus 8x minus 63. And then for this guy, the x minus 1 is going to cancel with the x minus 1. So you have a times the quantity x plus 3 times the quantity x squared plus 2. Then for this one, the x plus 3 is going to cancel with the x plus 3. So you have b times the quantity x minus 1 times the quantity x squared plus 2. Then lastly, the x squared plus 2 is going to cancel with the x squared plus 2. And so you're going to have the quantity cx plus d times the quantity x minus 1 times the quantity x plus 3. Like I talked about in the last section, you can use strategic substitution in some cases, not in every case, to make the problem easier to solve. You could go through and create a linear system by equating the coefficients and the constants if you want. That's going to take a long time. What I would prefer to do is look at the fact that if I let x be equal to 1, well, you have x minus 1 here, so this is going to go away. And you have x minus 1 here, so this whole thing's going to go away. So you'd be left with plugging in a 1 here, 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 and then here, and here. That's all you'd have to do, and then you could solve for a. So what you're going to have is negative 3 minus 14 plus 8 minus 63 is equal to your a times 1 plus 3, and then times this, you'd have 1 squared plus 2. Well, again, if you punch this part right here into the calculator, you're going to get negative 72. And then for this one right here, very easy to simplify. 1 plus 3 is going to be 4. Let me write that above, or actually let me just arrow to it below. This right here, 1 squared, is going to be 1 plus 2 is going to be 3. Well, essentially, you're going to have 4 times 3, which is 12. So the right side here is going to be 12a. So this, let me actually just do this off to the side. I don't want anybody to be lost. This right here is going to turn into 12a. And so this is where we're getting this from right there. Okay, so now all we're going to do is divide both sides of the equation by 12, and we're going to get that a is equal to negative 6. So when we come down here, we're going to plug in a negative 6 for that a right there. Then we're going to do the same thing. We're going to let x be equal to negative 3. Notice that you have an x plus 3 here, so this right here would go to 0. You have x plus 3 here, so this would go to 0. And so what you're looking at is plugging in a negative 3 here, 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 and here. Now be very, very careful when you do this, because you might end up with negative 3 squared, and if you don't wrap that in parentheses and you punch that into a calculator, you're going to get the wrong answer. Remember, something like this is negative 3 being squared. You have it again right there. That's negative 3 being squared. Make sure that when you do this, you key this in like this, negative 3 squared. Very easy to make a mistake there, and that'll throw the whole problem off. So when we plug in, you're going to get this for your left side. And then let me actually erase this. When you plug in, you're going to get this for your right side. So just punch the left side straight into the calculator. Again, this right here would be a middle step. This is another middle step. You're going to end up with negative 132. These two middle steps, I'm just putting that for clarity in case you need it. Maybe you key the wrong thing in and you get the wrong answer. You want to check where things are coming from. But you could just key this straight into the calculator. You're going to get negative 132. On the right side, negative 3 minus 1, that's going to be this negative 4 here. Negative 3 squared, again, that's wrapped in parentheses. That's positive 9. 9 plus 2 is 11. So you get negative 4 times 11 times b. That's negative 44b. So now we can just divide both sides of the equation by negative 44, and we get b is equal to 3. If we know something, we're going to replace it. So we're going to replace that b with a 3 right there, and now we're just left with these two unknowns. So c and then d. So we're going to let x be equal to 0. Everywhere there's an x, just mark it out because it's going to go away. So mark it out there and there and there and there and there and there and there. And just think about what you have left. So on the left side, you have negative 63. On the right side, you're going to have negative 6 times 3 times 2, and then plus 3 times negative 1 times 2, and then plus your d times negative 1 times 3. Again, these are things that you could just key into the calculator. The left side is really just going to stay as negative 63. On the right side, you have negative 42 minus 3d. We're going to add 42 to both sides of the equation, and you're going to end up with negative 21 is equal to negative 3d. Divide both sides by negative 3, you're going to get d is equal to 7. Okay, so once again, if you know something, plug it in. So d is equal to 7, so now you get a 7 there. So if you look, we haven't done anything really tough in terms of simplification. We're just plugging numbers in, and we're already down to where we just have one unknown. So that unknown is c right there. So how do I figure that out? So at this point, you could just pick any number that's not going to eliminate c in the process. So for example, you can't pick something like 1 because 1 minus 1 is 0. So don't pick something like that, but pick any other number. And I'm just going to choose to pick negative 1 for my x value. Again, you're just going to plug in, and then you're going to solve for c. So everywhere where there's an odd exponent, you're going to flip the sign of the coefficient. Let me put that one in there so I can show that. And where there's an even exponent, you just keep the coefficient. So negative 3 flips to positive 3. This stays as negative 14. Positive 8 flips to negative 8, and then you have negative 63. Then this equals, again, you're just going to be plugging in a negative 1 everywhere there's an x there. And remember, you got to make sure that you wrap that in parentheses to square it, and then plug in a negative 1 there, and then there, and then there. Let me get rid of this highlighting. So there, and then there. So if you plug that in, you're going to get negative 6 times 2 times 3 plus 3 times negative 2 times 3 plus your negative c plus 7 times your negative 2 times 2. Again, just go through and simplify. I'm just going to skip these middle steps here. You're going to end up with negative 82 is equal to 4c minus 82. If you add 82 to both sides, you would end up with 4c is equal to 0. Divide both sides by 4, and you're going to get that c is equal to 0, just like we have there. So again, we're just going to plug in. You're going to plug in a negative 6 for A. You're going to plug in a 3 for B. You're going to plug in a 0 for C. So again, if you're plugging a 0 in for C, this is going to go away. And then lastly, you're going to plug in a 7 for D. This gives me negative 6 over x minus 1 plus 3 over x plus 3 plus 7 over x squared plus 2. All right, for problem 2, we have 13x squared minus 7x plus 9 over 3x cubed plus 12x squared plus x plus 4. Again, look at the degree of the numerator. That's a 2. Look at the degree of the denominator. That's a 3. So this guy is going to be a proper fraction. So we're just going to factor the denominator. This is one you can do pretty easily using grouping. So from the first two, this 3x cubed plus 12x squared, you pull out the greatest common factor. So that's the 3x squared here. Inside you have x plus 4. From the second two, you could just pull out a 1. That's going to be your GCF here. And then inside you just say you have x plus 4. So you have this common binomial factor of x plus 4 here. Again, you're going to pull that out. So this equals the quantity x plus 4, and then times the quantity. You can have this 3x squared plus 1, and this 3x squared plus 1, you cannot factor that using rational numbers. Okay, so now we're going to set up the partial fraction decomposition. Again, we know the denominator is x plus 4 times this 3x squared plus 1 quantity. And so you're going to have your a over x plus 4. So again, that's coming from there. And then plus your bx plus c over your 3x squared plus 1. So coming from this guy right here. Okay, we're going to multiply both sides by the LCD, which is this x plus 4 quantity times the quantity 3x squared plus 1. And again, I have to break this up because it's just so long. So this right here would cancel with this right here, and you have your numerator. Then for this one, the x plus 4s would cancel. So you're going to have a times the quantity 3x squared plus 1. Then for this one, the 3x squared plus 1 would cancel with the 3x squared plus 1, and you're going to get the quantity bx plus c times the quantity x plus 4. Once again, you could set up a system if you want, but this one is where you could use strategic substitution and speed the process up. I'm going to start by letting x be equal to negative 4. Again, you have x plus 4 here, so if I plug in a negative 4 for x, this is going to go away. So what you would do is say, I'm plugging in a negative 4 there, and then here. Again, when you plug this in, make sure you wrap this guy in parentheses when you're keying this into your calculator. Very easy to make a mistake. Negative 4 wrapped in parentheses squared is positive 16. If you don't do that, your calculator is going to give you the wrong answer, and it's not going to match what I have here. So once we plug in and simplify, we're going to get 245 on the left is equal to, on the right, you're going to get 49a. Divide both sides by 49. You're going to get a is equal to 5. All right, now that we know that a is equal to 5, we're just going to replace that right here in our equation. And then what we're going to do next is we're going to let x be equal to 0. Notice that if we did that, this guy right here is going to get eliminated. So the only thing you have left in the equation is c, and so you'll be able to solve for that. So when you plug in a 0 for x, anywhere you have that, you could just mark that term out because it's basically going to go away. So this 13x squared, just mark that out. You can mark out the negative 7x. So those are both going to be gone. The left side is just going to be 9. And this equals, on the right side, you can mark this out, and I've already marked that out, and you can mark this out. So basically, you would have 5 times 1, which is 5, and then plus, you would have c times 4, which is just 4c. So 9 equals 5 plus 4c. We're going to subtract 5 away from each side of the equation, and that's going to give me 4 is equal to 4c. Divide both sides by 4. You're going to get c is equal to 1. Again, you can replace that c with a 1 because you know its value. So now we just need to figure out what is b. Again, at this point, you can just pick a number that's not going to eliminate this guy. And I'm just going to pick the number 1 because it's easy to work with. So if we let x be equal to 1, plug that in there, and then there, and then there, and then let me get rid of this highlighting here, and then also here. So what you're going to get is 13 minus 7 plus 9 is equal to 5 times 4 plus 5 times the quantity b plus 1. If you simplify on the left, you just punch this into a calculator, you're going to get 15. And this equals on the right, you're going to have 20 plus 5b plus 5. Now, 20 plus 5 is 25. Let me do this off to the side. This right here would end up giving you 15 is equal to, this would be 5b plus 25. So let me explain where this line's coming from. We're just going to subtract 25 away from each side of the equation. That cancels. 15 minus 25 is negative 10. So you get negative 10 is equal to 5b. So that's where this comes from. And then you just divide both sides by 5 and you get b is equal to negative 2. Okay, so we know that a equals 5, b equals negative 2, and c equals 1. So again, we're just going to plug into the model, and we're going to say that this is 5 over x plus 4, plus this is negative 2x plus 1 over 3x squared plus 1. All right, for problem 3, we have negative x squared minus 2x minus 3 over x cubed minus x squared plus 5x minus 5. If you look at the degree of the numerator, it's going to be 2, and the degree of the denominator is going to be a 3, so this is a proper fraction. And now we just want to factor the denominator. This is one you can factor using grouping. From the first two, you can pull out an x squared. From the last two, you can pull out a 5. So this is equal to x squared times the quantity x minus 1 plus 5 times the quantity x minus 1. So the x minus 1 here is the common binomial factor, so that gets pulled out. And we would say this is equal to the quantity x minus 1, and then times your quantity, you would have x squared plus 5 coming from this guy and this guy. Now, x squared plus 5, you can't factor that using rational numbers, so this is going to be an irreducible quadratic here. And so now we'll just set up the partial fraction decomposition. Again, if the denominator is x minus 1 and then times the quantity x squared plus 5, we're going to say that this guy right here is equal to a over x minus 1. So that's coming from this right here. And then plus your bx plus c over your x squared plus 5. So coming from this guy right there. All right, multiply both sides by the LCD. So the quantity x minus 1 times the quantity x squared plus 5. And again, this will not fit on the screen, so I'm just going to do it in parts and then reassemble it. So this would cancel with this, and you get the numerator, negative x squared minus 2x minus 3. Then these guys would cancel, so you get a times the quantity x squared plus 5. And then these guys would cancel, so you get the quantity bx plus c times the quantity x minus 1. Okay, so coming down here, we're going to do some strategic substitution. We're going to let x be equal to 1. So if I plug a 1 in right there, again, 1 minus 1 is 0, so this is going to go away. So that allows me to solve for a. Again, everywhere there's an x, plug in a 1, so there, and then there. Be very, very careful. This is going to cause an error for somebody. You have a negative on the outside there. So that is not negative 1 squared. In other words, this right here, if you did it like this, that's wrong in this case, because the negative is on the outside. So you want to put the negative of, then x gets replaced with 1, then you want to square it. So you key that into your calculator. This right here is going to be equal to negative 1. Be very, very careful in this section when you're plugging things in. Always wrap whatever you're plugging in for x in parentheses. That's going to keep you from making a sign mistake. So you just key it into your calculator that way. So this becomes the negative of 1 being squared minus 2 times 1 minus 3 is equal to a. And then you have this quantity 1 squared and then plus 5. So just key this stuff into the calculator. You're going to get negative 6 on the left is equal to 6a on the right. Divide both sides by 6. You get a equals negative 1. All right, since I know a is equal to negative 1, I can just replace that with a negative. If you want to put a negative 1 there, that's fine as well. And then I'm going to let x be equal to 0. So everywhere that there's an x, just mark it out. You can mark this out, and this out, and this out, and this out, and this out. And what do we have left? Well, on the left side, you have negative 3. Then this equals on the right side, you would have negative 5, and then over here you have c times negative 1, so that's just minus c. So this is negative 3 equals negative 5 minus c, and then from here you could add 5 to both sides. That would give you, let's see, negative 3 plus 5 is 2, so you would have 2 is equal to negative c, and then you could multiply both sides by negative 1, or you could divide both sides by negative 1, and you'd end up with c is equal to negative 2. Again, now that we know that c is negative 2, just replace it. And now we need to figure out what b is. Once again, pick a number that's not going to eliminate this guy. Any other number is fine. And essentially, if I plug in a negative 1 everywhere there's an x, again, be very, very careful. Plug in a negative 1 there, and there, and there, and then there, and then also there. Again, I'm just going to emphasize this because somebody's going to make a mistake. There's a negative out in front, and then you're plugging in a negative 1 for the x, and that's squared. This negative 1 right here squared is positive 1, but then you want the negative of that. That's how you get negative 1 here. I think the rest of this is fairly straightforward, so just go ahead and plug in. We're going to do some simplifying. We're going to end up with 4 is equal to 2b plus 4, and then if you subtract 4 away from each side, you're going to end up with 0 is equal to 2b, and you divide both sides by 2, and what are you going to get? Well, this is going to cancel, and you get 0 over 2, which is 0. So we can say that b is equal to 0, which is what we have right there. All right, so now we know that a equals -1, b equals 0, and c equals -2. Again, we're just going to plug in. So this would give us -1 over x minus 1 plus your -2 over x squared plus 5. All right, for problem 4, we have 8x squared plus 3x plus 23 over x cubed minus 3x squared plus 4x minus 12. So again, we're going to check to see if we have a proper fraction. And so the degree of the numerator is going to be 2, and then the degree of the denominator is going to be 3. So this means we do have a proper fraction, and we can just go into factoring. This is another one you can do using grouping. From the first two, you can pull out an x squared. So we could say this is x squared times the quantity x minus 3. And then from the last two, you could pull out a 4. So we'll go plus 4 times the quantity x minus 3. So the x minus 3 is your common binomial factor. Pull that out. Let's say this equals your quantity x minus 3. And then times, you're going to have this quantity x squared plus 4. That's coming from this guy and this guy. Now, x squared plus 4, again, you can't factor that using rational numbers. So that's going to be an irreducible quadratic. Now we're going to set up the partial fraction decomposition. So here we're going to have a denominator again of x minus 3 times the quantity x squared plus 4. So we would set this up and say this is a over your x minus 3. So again, that's coming from right there. And then plus bx plus c over x squared plus 4. Again, this is coming from this guy right there. All right, multiply both sides by the LCD. So the quantity x minus 3 times the quantity x squared plus 4. Again, this is not going to fit on the screen. So I'm just going to break it up and reassemble it. This guy right here is going to cancel with this guy right here. You're going to have your numerator, which is 8x squared plus 3x plus 23. Then this guy is going to cancel with this guy. So you can have a times the quantity x squared plus 4. Then this guy is going to cancel with this guy. And you're going to have the quantity bx plus c times the quantity x minus 3. All right, once again, we're going to use strategic substitution. So we're going to let x be equal to 3 because 3 minus 3 would be 0. So this guy right here would get knocked out. And so plug in a 3 everywhere else. Again, I think this is fairly straightforward. You're plugging in a 3 here, and then here, and then also here. You go through and simplify everything. You're going to get 104 is equal to 13a. And then if you divide both sides by 13, you're going to get a is equal to 8. Okay, we're going to replace the a with 8 there, and then we're going to continue. Again, another strategic substitution. So we're going to let x be equal to 0. So everywhere there's an x, just mark that guy out. So this is gone, this is gone, this is gone, this is gone, and this is gone. So on the left side, you just have 23, and that equals, on the right side, you'd have 8 times 4, that's 32. And then over here, c times -3 is -3c. So you would have 23 is equal to 32 minus 3c. What you would do here is subtract 32 away from each side. That would give you -9 is equal to -3c. And then you would divide both sides of the equation by -3, and you would get c is equal to 3. Okay, so we're going to replace our c with 3. So we did that there. And now we're going to, again, pick something to where we can solve for b. Just anything that doesn't eliminate this guy is fine. So we're going to say that we're going to let x be equal to 1, and you're going to plug that in there, and then there, and then there, and then there, and then also there. So fairly straightforward. You're going to get 8 plus 3 plus 23 is equal to, this would end up being 8 times 5, and then minus 2 times the quantity b plus 3. Again, just go through and simplify. You're going to end up with this 34 equals 34 minus 2b. You would subtract 34 away from each side. You would get 0 equals -2b. Divide both sides by -2. You get b is equal to 0. Okay, so we know that a equals 8, b equals 0, and c equals 3. So again, plugging in, we're going to have 8 over x minus 3 plus 3 over x squared plus 4. All right, for problem 5, we have -x cubed minus 2x squared plus 3x minus 1 over x cubed plus 4x squared plus 3x plus 12. In this case, you'll notice that the degree of the numerator is 3, and the degree of the denominator is also 3. So when that happens, and you have the degree of the numerator being the same as the degree of the denominator, that's an improper fraction. So what you need to do here is a polynomial long division. So I already set this up for us so we can go through it pretty quickly. So you're going to go leading term into leading term. So -x cubed divided by x cubed is -1. Then you're going to multiply, and then you're going to subtract. So I'm going to combine that into one step. I'm basically going to multiply and then flip the sign. Because multiplying by -1 changes the sign, and then we would change it back, just consider that if you multiplied it by 1, that would accomplish both things. So if you multiply everything here by 1, you're just copying what you have. So that's x cubed plus 4x squared plus 3x plus 12. Then just go through and say -x cubed plus x cubed, that's going to cancel. -2x squared plus 4x squared, that's going to be 2x squared. 3x plus 3x is 6x. And then -1 plus 12 is going to be 11. So this right here is your remainder. So when we set this up, we want to say that this is equal to -1, which is the quotient, plus 2x squared plus 6x plus 11, that's the remainder, over your divisor, or your denominator from this guy right here, which is x cubed plus 4x squared plus 3x plus 12. So what you want to do is just worry about this part right here. This is what we're going to do the partial fraction decomposition with. Do not worry about that -1 part. We'll put that on in the end when we write our final answer. Okay, so now we have our proper fraction. We're going to factor the denominator. So we're going to pull out an x squared from the first two and pull out a 3 from the last two. So that gives me this x squared times the quantity x plus 4 plus 3 times the quantity x plus 4. So x plus 4 is the common binomial factor. So that gets pulled out right there. And then what you'd have left is this x squared plus 3. This would be times the quantity x squared plus 3. Then your x squared plus 3 is going to be an irreducible quadratic here. We're not going to be able to factor that using rational numbers. So coming down, we're going to set up the partial fraction decomposition. Again, the denominator is x plus 4 times this x squared plus 3 quantity. So here, when you set this up, you have a over x plus 4. So that's coming from right there. And then plus bx plus c over x squared plus 3. So that's coming from this right there. All right, multiply both sides by the LCD. So the quantity x plus 4 times the quantity x squared plus 3. Again, this is not going to fit on the screen, so I'm just going to do this in parts. So this would cancel with this. You're left with the numerator, which is 2x squared plus 6x plus 11. For this one right here, the x plus 4 would cancel with the x plus 4. So we would have a times the quantity x squared plus 3. Then here, this guy, this x squared plus 3 would cancel with this x squared plus 3. You'd have the quantity bx plus c times the quantity x plus 4. And again, just putting everything together, you're going to get this guy right here. And once again, we're going to have something where we can solve it with strategic substitution. Plug in a negative 4 for x. Again, if you plugged in a negative 4 there, negative 4 plus 4 is 0. So this right here is going to go away. That's going to allow me to solve for a. Again, everywhere else, just plug in a negative 4. Be very careful with your signs there because it's negative. Again, this needs to be wrapped inside of parentheses like this. This is negative 4 being plugged in for x being squared. Then over here, it's also going to matter. So this is your negative 4 being squared. We're plugging it in here, but it's not as big of a deal. This is where people are going to make mistakes. So just key this into the calculator and simplify everything. You're going to end up with 19 equals 19a. And so you divide both sides by 19, you get a equals 1. And again, once you know that, you can plug that in. Now this one might be a little bit confusing. Let me go back up. If we plug in a 1 for a right there, we have 1 times the quantity x squared plus 3. So you can just drop the parentheses there and just say that's x squared plus 3. So that's where this is coming from right here. So now we'll just let x be equal to 0 so we can solve for c. So that's going to get rid of this and this and this and this and this. So you're going to have 11 is equal to, over here, 3, and then plus your 4c. Subtract 3 away from each side of the equation. You're going to get 4c equals 8. Divide both sides by 4, and you're going to get c is equal to 2. Okay, so plug in a 2 there where c was, and just continue. Now you can solve for b. Again, plug in any number you want for x, as long as it doesn't make this go away. You're okay. So I'm just going to pick an x value of 1. Easy to work with, so it's going right there, and then right there, right there, right there, and right there. So this is completely straightforward. If you go through and simplify, you're going to end up with 5 equals 5b, and you're going to get b is equal to 1 when you divide both sides by 5. Okay, so a equals 1, b equals 1, and c equals 2. So that tells me that this is going to be 1 over x plus 4 plus x plus 2 over x squared plus 3. This is where people tend to make mistakes. So either mistake number 1, you forget to do the long division, or mistake number 2, you do the long division and then you forget about it because it's so far up on your page because these problems are very tedious and you need lots of paper. So try to make a little marking somewhere on each page that you're working with that you have to come back and include this quotient here of negative 1 when you do this. Remember that when we started with this guy, we wrote it as negative 1 plus this 2x squared plus 6x plus 11, that was a remainder, over your denominator, which was x cubed plus 4x squared plus 3x plus 12. Well, this right here is what we just did the partial fraction decomposition for. And that is going to turn into this right here. So when you write your final answer for this guy, you're going to say it's negative 1 plus your 1 over x plus 4, and then plus your x plus 2 over your x squared plus 3. All right, for problem 6, we have x cubed plus x squared plus 3x plus 8 over x cubed minus 4x squared plus 4x minus 16. So in this case, if we look at the degree of the numerator, it's going to be 3. And if we look at the degree of the denominator, it's also 3. So once again, if the degree of the numerator is the same as the degree of the denominator, you have an improper fraction and you have to do polynomial long division first. All right, so I've already set this up for us. Remember, you're going to start by doing leading term into leading term. So we're basically going to do x cubed divided by x cubed, and that's going to give me 1. So that's going to be my quotient. And I'm going to multiply this by this guy, and then I'm going to change the sign of everything. Remember, you multiply and then you subtract. To do this in one step, just multiply this by negative 1. And so you would have x cubed will become negative x cubed, and then negative 4x squared will become plus 4x squared, plus 4x would be minus 4x, and then minus 16 would be plus 16. So now you can just add. So x cubed minus x cubed, that's going to cancel. X squared plus 4x squared, that's 5x squared. 3x minus 4x is negative x. And then lastly, 8 plus 16 is 24. So the quotient is 1. And then your remainder is going to be 5x squared minus x plus 24. So the way we're going to write this, we're going to say it's 1. Again, that's your quotient. plus 5x squared minus x plus 24, that's your remainder, over your divisor. So x cubed minus 4x squared plus 4x minus 16. Now this guy right here, which I've written on this page, this is what we're going to be doing the partial fraction decomposition with. When we're done, we can go back and we can slap that 1 out in front. So we can go 1 plus, and then we'll put our partial fraction decomposition of this. And we're just going to factor the denominator. Again, something we can factor very easily. So we would pull x squared out from the first two. You'd have x squared times the quantity x minus 4. And then from the last two, you'd pull out a 4. So plus 4 times the quantity x minus 4. Again, this right here is a common binomial factor. So it gets pulled out. And then what you have left is this guy and this guy. So that's going to be this factor right here. So this turns into the quantity x minus 4 times the quantity x squared plus 4. And again, x squared plus 4, that's an irreducible quadratic. So once again, we're going to set up the partial fraction decomposition. The denominator is x minus 4 times this quantity x squared plus 4. And so what you get is a over x minus 4, again coming from this guy, plus bx plus c over x squared plus 4 coming from this guy. All right, so multiply both sides by the LCD. So we have x minus 4, then times x squared plus 4. Once again, I can't fit this on the screen, so I'm just going to break it up and then reassemble it. This would cancel with this, so you get your numerator. That's 5x squared minus x plus 24. Then this would cancel with this, and so we get a times the quantity x squared plus 4. And then this right here would cancel with this right here. So you get the quantity bx plus c times the quantity x minus 4. Okay, putting everything together, this is what we're going to have. Again, we're going to do strategic substitution. Notice you have x minus 4 here as a factor. So if you let x be equal to 4, again, 4 minus 4 is 0. This is going to go away. So we're just going to be able to solve for a here. And everywhere else, you're just going to plug in a positive 4. So again, there shouldn't be too many issues here. So this right there, and then right there. Again, just go through and punch this into your calculator on each side. You can follow these steps if you need to. But essentially, you're going to get 100 equals 28, divide both sides by 20, and you're going to get a is equal to 5. All right, the next thing we're going to do is replace our a with 5. And then we're going to plug in a 0 for x. That way we can solve for c. So everywhere there's an x, just mark that out. So here, and then here, here, and then here, and then here. So you're left with 24 on the left is equal to, on the right, 5 times 4 is 20. And then you'd have c times negative 4, that's going to be minus 4c. And then subtract 20 away from each side. You're going to get 4 equals negative 4c. Divide both sides by negative 4. You get c equals negative 1. Okay, we're going to replace c with a negative 1 there. And now we're going to let x be equal to 1. Again, pick any number you want, as long as it doesn't get rid of this guy right here. And so if you plug in a 1 everywhere there's an x, so there, and then there, and then there, and then also there, you're going to produce this guy right here. Again, just go through and simplify. You're going to end up with 0 equals negative 3b. Divide both sides by negative 3. You're going to get b is equal to 0. Okay, so at this point, we know that a is equal to 5. B is equal to 0, and C is equal to negative 1. So we're just going to plug in. We're going to get 5 over x minus 4, then plus negative 1 over x squared plus 4. Now we're not done because remember, we had to do a polynomial long division when we started. So we're going to come back to this part right here. So remember, we started by saying this was equal to 1 plus, this was the remainder, so 5x squared minus x plus 24, over this was your divisor, so x cubed minus 4x squared plus 4x minus 16. So we did partial fraction decomposition with this guy right here. And if we think about it, this guy is now this guy right here. So when you want to write your final answer, you put your 1 plus, and then 5 over x minus 4 plus negative 1 over x squared plus 4. All right, for problem 7, we have 3x to the 4th power plus 2x cubed minus 19x squared minus 2x plus 28 over the quantity 2x minus 1 times the quantity x squared minus 3 squared. All right, the first thing we would ask here is this a proper fraction? How do you get the degree of the denominator when it's in factored form? Well, one thing you could do, which I don't suggest, is you could simplify this completely. You would get 2x to the 5th power minus x to the 4th power minus 12x cubed plus 6x squared plus 18x minus 9. Should you do this? Absolutely not. You would get the right answer, right? You'd come up with a degree of 5, but you do too much work to do it. The only thing you have to think about here is when you go through and multiply this, if each one of these is in standard form, then you have 2x minus 1, and then you could write this as x squared minus 3, and then times x squared minus 3 again. Well, what's going to end up happening is this leading guy times this leading guy times this leading guy, well, that's going to give you your term with the highest power on x. So if I did 2x times x squared again, this is 2 times x to the power of 1 plus 2 plus 2, which is 5. So that right here is going to match this right here. Okay, so that's all you have to think about. And to make this even shorter, what we could have done is not even written that way. You can just keep this in exponential form and just say, okay, well, x squared is going to end up being squared. That's x to the 4th power. And then forget about the 2. You don't even worry about it. X to the 4th power times x is x to the 5th power because you only care about that exponent right there. That's going to give you your degree. So coming back up, you would say the degree down here is 5. The degree up here is 4. So this is a proper fraction. Okay, since the denominator is already factored for us, we don't have to do that. We can just go straight into setting up the partial fraction decomposition. So this is our denominator here. So you would have a over 2x minus 1. That comes from this. And then plus, again, here's where the confusion comes in. This guy right here is squared. So that means I need a bx plus c over x squared minus 3. This right here is the x squared minus 3 to the first power. You've got to have that. You need a fraction for each power of this guy. So for the first power and then for the second power. So plus dx plus e over x squared minus 3 quantity squared. This is why these problems start to get out of hand very quickly, because now you have a lot of stuff you have to solve for. You have a, b, c, d, and e now. We're going to multiply both sides by the LCD. So this guy right here, and of course it's not going to fit on the screen, so I'm just going to break it up like I've been doing. This would cancel with this and give you your numerator. So you have 3x to the fourth power plus 2x cubed minus 19x squared minus 2x plus 28. Then this is going to cancel with this. You get 8 times the quantity x squared minus 3 squared. Then this guy right here is going to cancel with one of these. So you get the quantity bx plus c times the quantity 2x minus 1 times the quantity x squared minus 3. So this guy is very long. And then lastly, this is going to cancel with this. So you get the quantity dx plus e times the quantity 2x minus 1. This is a very, very long problem. It's very tedious, and unfortunately, it's very hard to use shortcuts here. You can use one shortcut to figure out what a is, and I would suggest you do it because it's going to make your life a lot easier. Unfortunately, what you're going to have to do is you're going to have to set 2x minus 1 equal to 0, and you're going to have to solve that. So add 1 to both sides. You get 2x is equal to 1, divide both sides by 2. This cancels, that's a terrible 2. Let me fix that. And so you're going to get x is equal to 1/2. What that means is that if I plug in an x value of 1/2, then 2 times a half is 1, 1 minus 1 is 0. So this is going to go away. And then again, this right here would be 0, so this whole thing's going to go away, and that's going to allow me to solve for a. The downside is I'm using a fraction here, and so when something like this comes up, no matter what you do, it's going to be time consuming. So you're going to spend a lot of time on this problem. So I'm going to let x be equal to 1/2. This is the left side. Again, I just split this up for convenience. Your calculator might do fractions or it might not. If you want to use an online calculator like Mathware or something like that, that's fine in this circumstance because it's just so tedious. Go ahead and just plug this in. You're going to end up with this 3 over 16 plus 2 over 8 minus 19 over 4 plus 27. I did not simplify this guy right here. And the reason is because we're going to have to get a common denominator. The other thing that might be confusing is this right here, this negative 2 times a half is negative 1. So negative 1 plus 28 is 27. So that's where this guy is coming from, that plus 27. Okay, everything else should be straightforward for you. So what we're going to do is go through and get a common denominator. So the least common denominator is going to be 16. So I'm going to multiply this by 2 over 2. I'm going to multiply this by 4 over 4. I'm going to multiply this by 16 over 16. And I'm going to end up with 3 plus 4 minus 76 plus 432 over 16. And this is going to give me 363 over 16. Now for the right side, we're going to have a times the quantity x squared minus 3 squared. And again, we're going to plug in a value of 1/2 everywhere there's an x. So there's just an x right there. So this turns into a times this quantity here. You have 1/2 being squared minus 3. And again, this is squared right here. So if you square 1/2, you're going to get 1/4. So we'll say this equals a times the quantity 1/4 minus 3. And then this is squared. What we have to do now is get a common denominator. So off to the side, let's say we had 1/4 minus 3. Well, you'd multiply this by 4 over 4. You could write this over 1 if you want for clarity. This would be equal to, well, you would say it's 1/4, and then minus, we'd have 3 times 4, that's 12, over 1 times 4 is 4. So now you have a common denominator. So that's where this is coming from down here. So we'll say this equals a times the quantity, 1/4 minus 12/4, and this is squared. So this is a times, you have this negative 11/4 being squared. Well, if you square a negative, you get a positive. So forget about the negative sign. If you square 11, you get 121. And if you square 4, you get 16. So this becomes 121 over 16a. If we put the two sides together, so we have 363 over 16 is equal to 121 over 16a. You can multiply both sides by 16. You're going to get 363 is equal to 121a. And then let me actually just rearrange this. I'll put 121a is equal to 363. All you have to do at this point is divide both sides of the equation by 121. This would cancel, and you're going to get that a is equal to 363 divided by 121 is going to be 3. So that's where this a equals 3 is coming from. You're going to replace your a with 3, so that's going to go right there. And then what I'm going to do is actually simplify this equation by subtracting this guy away from both sides. In other words, what I want to do is I want to go 3x to the fourth power plus 2x cubed, let me fix this, minus 19x squared minus 2x plus 28 minus this guy right here. So 3 times the quantity x squared minus 3. That quantity there is squared. In other words, this is going to make it to where this goes away and this left side here is more simple. So get rid of this. I've already done this on the other page. Let me go down here. First, we're going to expand this, and we're going to say it's 3 times the quantity x to the 4th power minus 6x squared plus 9. Then we're going to distribute the 3 in. So this is 3x to the 4th power minus 18x squared plus 27. Then we're going to take our left side. So this right here is our left side. Again, just going back up, that is coming from right here. It's just copied from there. And what we're going to do is we're going to subtract this away. So this is minus, again, this right here matches this right here. Make sure that you're distributing that negative to each guy. So this is negative 3x to the 4th power plus 18x squared minus 27. So just go through and see what you can cancel. So 3x to the 4th power, you have that here, and then you have minus 3x to the 4th power. You have your plus 2x cubed. I'm just going to put a dot there to show we used it. And let me just put a dot there. Then you have your minus 19x squared, and then plus 18x squared. Well, that's going to give you negative x squared. And then you have your minus 2x, so nothing to combine with that. Let me put a dot there so that's clear. Put a dot there. And then you have your 28 minus 27, so that's going to be plus 1. So this right here, this 2x cubed minus x squared minus 2x plus 1, that is going to be the left side. So that's going to be right there. And then on the right side, you got rid of that other guy. So this part right here is removed. This part is simplified. So looking at what we have left, now we have to do this part right here, and we have to do this part right here. So that is going to be very tedious. All right, so if we go through and simplify this guy, I have the steps listed for you. We're going to end up with 2bx to the 4th power minus bx cubed plus 2cx cubed minus cx squared minus 6bx squared plus 3bx minus 6cx plus 3c. Then the other guy we need to simplify is this one. It's more straightforward. We'll say this is 2dx squared minus dx plus 2ex, then minus e. Okay, so I put this together, and again, it's so long that I had to break it up like this. And so what we're going to do is start with this form right here, and then I'm just going to rearrange things to where the like terms are next to each other. So we have 2x cubed minus x squared minus 2x plus 1 is equal to, you have 2bx to the 4th power. You don't have anything else with the 4th power there. Then minus bx cubed plus 2cx cubed, then minus cx squared minus 6bx squared plus 2dx squared plus 3bx minus 6cx minus dx plus 2ex plus 3c minus e. Okay, the reason you do that is so you can factor out when something's common. So again, over here you see I have 0x to the 4th power, and I'm just putting that in because I'm going to match this up with this. If you have a power on one side, but you don't have it on the other, you can always just use 0 as a placeholder. That's going to be your coefficient for the power that's missing. So that means that 2b, again, that's going to be the coefficient for x to the 4th power, is equal to, what's the coefficient for x to the 4th power here? It's 0. So that's going to be your first equation of the system. Second equation of the system, you're going to say this negative b plus 2c, that's your coefficient for x cubed. That's going to be equal to 2. And then the third equation of the system, let me put this over here. You're going to have negative c minus 6b plus 2d is going to be equal to negative 1, because that's the coefficient for x squared. So negative c minus 6b plus 2d is equal to negative 1. Fourth equation of the system, we're going to have 3b minus 6c minus d plus 2e. So 3b minus 6c minus d plus 2e is equal to, well, this is going to be negative 2, so that's the coefficient of x. And then the fifth equation of the system, you're going to have 3c minus e is equal to 1. You don't actually need this fourth equation right here. You can get rid of it because 2b equals 0. You can just say that b equals 0. You can simplify that. You can use this one to figure out what c is, and then you can use b and c to figure out what d is, and you could use this one to figure out what e is. So you could get rid of this one. I think it's too complicated to work with. Let's put this one right here and move this up. Okay, so I wrote this more neatly. Again, for equation 1, you could again just use b is equal to 0. And then you could just plug in to figure out, well, this is negative 0, which is just 0, plus 2c equals 2. Well, for this one, if you have 2c equals 2, you can divide both sides by 2, and you can find out that c is equal to 1. Then for this one right here, we could plug in. So let me say that I'm working on this one right here. So you'd have the negative of c is 1, minus 6 times b is 0, and then plus 2 times d, don't know what that is yet. This equals negative 1. Well, you basically can get rid of this. So you'd have negative 1 over here, negative 1 over here. Well, you can just get rid of that. You could add 1 to both sides and say this is a 0 over here. Divide both sides by 2. And so now you know that d is equal to 0. So d is equal to 0. And then you have 3c. Again, c is 1. So this would be 3 times 1, which is just 3. Minus e is equal to 1. You can actually add e to both sides. I think that's a little bit faster. And subtract 1 away from each side. So get rid of this and get rid of this. So e would be equal to 3 minus 1, which is 2. Let me just write that e is equal to 2. We know b is 0, c is 1, d is 0, e is 2. And remember earlier we figured out that a was equal to 3. Okay, so coming back, we're just going to plug in. So we want 3 over 2x minus 1 plus 1 over x squared minus 3 plus 2 over the quantity x squared minus 3 squared. All right, let's take a look at problem 8. So here we're given negative 7x to the 4th power plus x cubed minus 14x squared plus 4x minus 7. This is over x times the quantity x squared plus 1, and this is squared. So once again, we need to figure out if we have a proper fraction or not. We know that the degree of the numerator is going to be 4, but what's the degree of the denominator? Again, you could go through and simplify this, but I'm going to tell you that's a waste of time. So you could go through and say this is x to the 5th power plus 2x cubed plus x. But if you didn't do this, the quick way is to look at your leading term right here, again, provided this is in standard form. So this is x squared, and then this is going to be squared. So that would produce x to the 4th power from that right there. Then you would end up multiplying this by x, and that's going to give you x to the 5th power. So I only care about this exponent here. Notice that the x to the 5th power matches the x to the 5th power. So that's all you have to do. You don't have to go through and simplify this whole thing. So coming back, we would say that the degree of the denominator is 5. And so we do have a proper fraction. Okay, so we want to set up the partial fraction decomposition. This is the denominator. So x is a linear factor. Again, anything of the form ax plus b, where a and b are real numbers. So this is 1x plus 0, if you want to think about it that way. So you're going to have, when this sets up, a over x, again, a is the unknown constant, over x, again, that's your linear factor from here. And then because this guy is an irreducible quadratic that's being squared, well, again, you want to say that you have bx plus c over x squared plus 1. So again, you could wrap this and put this to the 1st power to make that more clear. And then you have plus your dx plus e over x squared plus 1. So this quantity is squared. So you've got to have a fraction for the 1st power and then also for the 2nd power. Now we're going to multiply both sides by the LCD. So x times the quantity x squared plus 1 squared. And so again, we cannot fit this on the screen. So I'm just going to break it up and then I'll reassemble it. This is going to cancel with this. And so you get your numerator, negative 7x to the 4th power plus x cubed minus 14x squared plus 4x minus 7. Then coming down here, this is going to cancel with this. You're going to get a times the quantity x squared plus 1 squared. Then coming down here, this one's going to cancel with one of these. So first you're going to multiply x times this quantity bx plus c. That's going to give you bx squared plus cx. Then you're going to multiply by this quantity, which is x squared plus 1. Then lastly, this guy would cancel with this guy. So we're going to get dx plus e. That's a quantity times x. So you get dx squared plus ex. All right, again, putting this together, it's quite long, but the first thing you're going to do is plug in a 0 for x. And the reason you're going to do that, if you plugged in a 0 there and you plugged in a 0 there, this guy right here is going to be 0, and 0 times anything is 0. So this whole thing's going to go away. This is going to go away, and this is going to go away. So that allows me to solve for a. So I'm going to come through and mark out this, and this, and this, and this. So really on the left, you're just going to have negative 7. And then on the right, let me fix this. Let me write negative 7 again. On the right, you're going to have, this guy's gone. So you would just have 1 squared, which is 1 times a. So negative 7 is equal to a, or you could say a equals negative 7. So that's the first part. Remember, you're going to plug in a negative 7 for a there. And we're actually going to simplify this, again, just like we did in the last problem, because what I want to do is actually subtract this away from this right here. In other words, you want negative 7x to the 4th power plus x cubed minus 14x squared plus 4x minus 7. And you want to remove this from this side to make it simpler. So minus, I'll just put this in brackets. Your negative 7 gets plugged in for a, and then times the quantity x squared plus 1. Again, this is a quantity squared here. Close that down. Maybe that 2 could be better. So this is what we're going to do on the next page. So I have this set up for us. So again, I'm going to expand this first. And so this equals negative 7 times the quantity x to the 4th power plus 2x squared plus 1. Then distribute the negative 7 in. So this equals negative 7x to the 4th power minus 14x squared minus 7. Okay, so now what we're going to do is we're going to take this guy right here, which is our left side. Again, the negative 7x to the 4th power plus x cubed minus 14x squared plus 4x minus 7. Just to be clear, that's coming from right there. Again, that's the left side of the equation. What we're going to do is we're going to subtract away this guy right here. So it's inside of parentheses. That's just coming from right there. So when we do this, we're going to distribute that negative to each guy inside the parentheses. So you get plus 7x to the 4th power plus 14x squared and then plus 7. So now you're just going through and combining like terms. That's all you have to do. So negative 7x to the 4th power and then plus 7x to the 4th power. Those are going to go away. You have x cubed here. That's going to go right there. There's nothing to combine with that. You have negative 14x squared and plus 14x squared. That's going to go away. You have plus 4x, nothing to combine with that. Then you have negative 7 and then plus 7. So that's gone. So at the end of the day, this is going to be equal to x cubed plus 4x. Let me put a dot there just to match up with that. All right, so now we have a simplified equation. So the left side becomes x cubed plus 4x, and this equals, on the right side, we're going to have this quantity bx squared plus cx times the quantity x squared plus 1 plus the x squared plus the x. So what we're going to do is simplify this guy. So we would get this guy right here, and then we're going to put this guy into standard form and basically put the like terms next to each other. That way we can end up factoring and then equating the coefficients. What you're going to notice is that on the left side here, I put in a 0 as the coefficient for x to the 4th power because we're missing x to the 4th power over here, but we have x to the 4th power here. Then also, if you look through it, here you have x cubed and here you have x cubed, so you're okay. But then here, you're going to have this 0x squared. So again, I'm going to use 0 for that x squared because I have an x squared over here. And then of course, we do have this 4x. So we have this right here, and then we have an x right there. So let me go through, and we're just going to set up our linear system. So the first thing is that 0, which is the coefficient of x to the 4th power, would be equal to b, which is the coefficient for x to the 4th power. So that's the first equation of the system. Just b is equal to 0. Second equation of the system, you can put a visible 1 there. So 1 is the coefficient for x cubed here, and c is the coefficient for x cubed here. So we could just say that c is equal to 1. And then the third equation of the system, let me fix this 3. If we go through here, we would say 0, which is the coefficient of x squared, is equal to b plus d, which is the coefficient for x squared over here. So b plus d is equal to 0. So then the fourth equation of the system, we're going to say that 4, which is the coefficient for x to the 1st power, is equal to c plus e, which is the coefficient for x to the 1st power over here. So let's go c plus e is equal to 4. Okay, so I wrote this more neatly on this page here. We know that b equals 0 and c is equal to 1, so we don't have to do anything there. For the third equation of the system, we have b plus d equals 0. Well, if b is equal to 0, that means that this would just go away, and you could say that d is also equal to 0. And then for this guy right here, you could plug in for c. You're plugging in a 1, so you would have 1 plus e is equal to 4. You would subtract 1 away from each side of the equation. This would cancel, and you would say that e is equal to 4 minus 1 is 3. So let me get rid of this. Now remember that we know that a equals -7. That's something we figured out at the beginning of the problem. So we can say a equals -7, b equals 0, c equals 1, d equals 0, and e equals 3. So just plug into the model. You're going to get -7 over x plus 1 over x squared plus 1 plus 3 over the quantity x squared plus 1 squared. All right, for problem 9. We have 3x cubed minus 2x squared minus 3x minus 2. This will be over the quantity x squared minus x minus 1 squared. And again, if you want to know if this is a proper fraction, just think about the fact that the degree up here is 3. The degree down here, you're going to have x squared that gets squared. So forget about everything else. That's going to give me x to the 4th power. So I know the degree up here is 3. The degree down here is going to be 4. So this is going to be a proper fraction. All right, so we're going to set up the partial fraction decomposition. Again, this is my denominator. This is squared here, so you've got to have the first power and then squared. So ax plus b over x squared minus x minus 1, so that's for the first power, then plus your cx plus d over the quantity x squared minus x minus 1 squared. Okay, multiply both sides by the LCD. So this guy here, once again, we can't fit this on the screen, so we're just going to break it up. So this is going to cancel with this. You have the numerator, 3x cubed minus 2x squared minus 3x minus 2. Then this part right here is going to cancel with one of these. So you have the quantity ax plus b times the quantity x squared minus x minus 1. And then lastly, this right here would cancel with this right here completely. So you just have cx plus d. Okay, so putting this together, you're going to have 3x cubed minus 2x squared minus 3x minus 2 is equal to the quantity ax plus b times the quantity x squared minus x minus 1, then plus the x plus d. So looking at it, I'm going to break it up. So this will be my left side. It's not going to change. On the right side, I'm going to simplify this. So this will turn into ax cubed minus ax squared minus ax plus bx squared minus bx minus b plus the x plus d. And then all I'm going to do is put like terms next to each other. So we're going to end up with 3x cubed minus 2x squared minus 3x minus 2 is equal to ax cubed minus ax squared plus bx squared minus ax minus bx plus cx minus b plus d. All right, so coming down here, once again, we're just going to match things up. We're going to equate the coefficients and the constants to build our system. So the first one's easy. We have 3 as the coefficient of x cubed, and then here we have a as the coefficient of x cubed. So we're just going to say for the first equation of the system that a is equal to 3. Then continuing, you have this -2, that's the coefficient of x squared, and then you have -a plus b, that's the coefficient of x squared there. So the second equation is -a plus b is equal to -2. Then continuing, we have -3 as the coefficient for x to the first power, and then here we have -a minus minus b plus c as the coefficient for x to the first power. So you get negative a minus b plus c is equal to negative 3. So that's your third equation of the system. And then the fourth equation of the system, you're just going to set this negative 2 right here equal to this negative b plus d. If you need to on any of these, remember you can always go plus negative just so that the sign here, so this guy right here matches completely with this. But again, that's going to be personal preference. Just remember that you're setting this guy right here equal to this guy right here. So you get negative b plus d is equal to negative 2 for your fourth equation. Okay, so going through and just substituting, if a is equal to 3, you could plug a 3 in for a right there. And what you're going to have is put the negative out in front, and then you have 3, and then plus b is equal to negative 2. We're going to add 3 to both sides of the equation. This right here is going to cancel, and we're going to say that b is equal to negative 2 plus 3 is 1. So we know that b is equal to 1 now. Let me get rid of this, and I'll just put that b is equal to 1. So for the third equation, we know a and we know b. So we're just going to plug in. So let's say that negative, and then for a, that's 3. So this is just negative 3. And then minus b. b is 1, so minus 1. And then plus c is equal to negative 3. Well, negative 3 minus 1, that's going to be negative 4. So let's put this as negative 4. And then let me scooch this over a little bit. And let's add 4 to both sides of the equation. This right here is going to cancel. So we're going to end up with c is equal to negative 3 plus 4. That's going to be 1. So let me get rid of this. And let me arrow to this like this. So c is equal to 1. And let me get rid of this. Okay, the last equation is negative b plus d equals negative 2. So again, for b, it's 1. You got that negative out in front. So let's put negative 1. Plus d is equal to negative 2. Let's go ahead and add 1 to both sides of the equation. This right here is going to cancel. And what we're going to have is that d is equal to negative 2 plus 1 is going to be negative 1. So what we have is that a is equal to 3, we have b is equal to 1, c is equal to 1, and d is equal to negative 1. So coming down here, again, a equals 3, b equals 1, c equals 1, and d equals negative 1. We just plug into the model. We're going to get 3x plus 1 over x squared minus x minus 1 plus x minus 1 over the quantity x squared minus x minus 1 squared. All right, so for problems 10 and 11, they basically go together as one problem. I just split it up, but this is a common problem you're going to see in your textbook. So for the instructions, we're going to find A, and this is a capital A, capital B, capital C, and capital D in terms of this lowercase a and lowercase b. When we come down here, this is what we're given. So we don't have to do our normal steps because everything's kind of set up for us. And what we have is this ax cubed plus bx squared over the quantity x squared plus 3 squared. Now this is a lowercase a and a lowercase b. So we're saying this is equal to, you have ax plus b over x squared plus 3 plus cx plus d over the quantity x squared plus 3, and this is squared. Now this a, this b, this c, and this d, those are all capital letters. What you want to do, or your goal here, is to have your a, your b, your c, and your d, those capital letters, put in terms of these lowercase letters. This is actually a lot easier than it sounds. All you need to do is go through your normal steps. So the first thing you would do is just multiply both sides by the LCD. And so the LCD here is x squared plus 3 quantity squared. And so I have that right there. And basically, again, this is not going to fit on the screen, so we'll just go through it piece by piece. This is going to cancel with this. You have your numerator, which is ax cubed plus bx squared. Again, these are lowercase letters. Then here, this is going to cancel with one of these. So you have ax plus b, again, uppercase letters, and then times your x squared plus 3. And then now this is going to cancel with this, and you have your cx plus d. And again, these are uppercase letters. Okay, going through, all you're going to do is simplify like you normally do. So you're going to end up with ax cubed plus bx squared is equal to your ax plus b times your x squared plus 3 plus cx plus d. So on the right side here, we're dealing with capital letters. On the left side, we're dealing with lowercase letters. So all you have to do is simplify this to this, and then you're going to put like terms next to each other, and then you're going to factor. Now, at this point, what you'll notice is that you have x cubed here and x squared here. So here's x cubed and here's x squared. But on the right side, you have an x, and then you have basically a constant. You don't have that stuff over here. So you're going to put plus 0x and then plus 0. Let me show you that here. So I wrote the left side as ax cubed plus bx squared plus 0x plus 0. Again, these are lowercase letters. On the right side, this is already set up for us. I just copied from the previous page. So notice that if you equate the coefficients, this uppercase a is going to be set equal to this lowercase a. So uppercase A or capital A is equal to lowercase a. Then the same thing is going to happen with this b. So the capital letter b is going to be set equal to the lowercase b. And then you have this, let me do this in a different color, 3a plus c, that's the coefficient for x, is equal to 0 because that's the coefficient for x here. So there's your 3a plus c equals 0. And then for this one, let me do one more color. This is 3b plus d, that's your constant here, that's set equal to 0. So here's your 3b plus d equals 0. Once we have this set up, it's pretty easy. You're just going to go through And in this one, you're going to say, okay, well, this capital or uppercase A is equal to lowercase a, so I'm just going to plug that in. So 3a plus c is equal to 0, and we're just going to subtract this 3a away from each side of the equation. And so now I can say that c is equal to negative 3a, and that's lowercase a. So this c right here is equal to negative 3a. Again, we're putting things in terms of this lowercase a and lowercase b. So that matches what we want. Then for this one right here, d is going to be equal to what? Well, again, you just do the same thing. This uppercase b is equal to the lowercase b. So you can say 3 lowercase b plus d is equal to 0. Subtract 3b away from each side. And we're going to say that d is equal to negative 3b, just like that. Okay, so let's go down. So this lowercase a gets plugged in here, so it's going to show up there. Lowercase b gets plugged in there, so it's going to show up right there. Negative 3a gets plugged in for this c, so that gets plugged in right there. And then negative 3b gets plugged in for d, so that shows up right there. And you could write this differently if you wanted to. Sometimes the book will write this as ax plus b over x squared plus 3. You could factor out the negative because it's there and there, so pull it out and put it in front. So you could write this as minus 3ax plus 3b, and make that 3 better, over the quantity x squared plus 3 squared. So this answer's fine and this answer's fine. Again, you want everything in terms of this lowercase a and lowercase b. But what we're going to do is we're going to roll into our problem 11, where we're going to use this solution to quickly find this. So usually there's a follow-up problem. You just have to figure out that in this case, your lowercase a is 5, and then your lowercase b is going to be 2. And then once you do that, you can just fill in the model. That's all you have to do. So we would say equals, let me write this here for reference. Lowercase a is equal to 5. And lowercase b is equal to 2. So everywhere you see a lowercase a, just put in a 5. This is 5x plus, everywhere you see a b, a lowercase b, you put in a 2. So this is a 2 over x squared plus 3. And then plus, this is negative 3 times a is 5. Again, lowercase a to be more specific. And then times x minus 3 times the lowercase b is 2. This is over your quantity x squared plus 3 squared. Okay, so negative 3 times 5 is negative 15. So negative 15. And then negative 3 times 2 is negative 6. And that's basically your answer. You might see it written differently if you did this problem in a textbook. Again, you could factor out the negative. So this can come out if you want. So you could say this is 5x plus 2 over x squared plus 3. This can come out. So you can say it's minus 15. Let me fix that. X, and then you'd have plus 6. Let me fix this. Over the quantity, this would be x squared plus 3, and this is squared. If you wanted to check this, it's actually quicker to go through and add these guys together by getting your common denominator, and you can prove that this plus this will give you this. You can go through and do the partial fraction decomposition if you want, but basically in problem number 10, we already did that. We just used a lowercase a for 5 and a lowercase b for 2. So you can do it that way if you want. I'll leave that one up to you. I'm just going to show it the other way, which is just to get a common denominator. So that's what we're doing here. We're going to multiply this by x squared plus 3 over x squared plus 3. And then we're going to add these guys together. We're going to go through and distribute things in the numerator. I'm going to end up with 5x cubed plus 15x plus 2x squared plus 6 minus 15x minus 6. So that's my numerator. Again, over that denominator, which is the quantity x squared plus 3 squared. If you look in the numerator, you have 5x cubed, which is going to come down here. You have plus 15x and then minus 15x. That's going to go away. Then plus 2x squared, that's going to go in your numerator. Then here you have plus 6 and then minus 6. So those guys are going to cancel. So we're going to say this equals your 5x cubed plus 2x squared over, you have the quantity x squared plus 3 squared. So the fact that we got this back shows that this was the correct partial fraction decomposition.